Okay, so in this video, we are going to be looking at another way to calculate normal distribution percentages. And the first question that you should have been asking yourself when we learned the 68, 95, 99.7 rule is what if there's a number of standard deviations that's not 1, 2, or 3? What if there's decimals or fractions, okay? And that's the question we'll look at right now. So you might be wanting some examples, and here they come. So what percent of data is below negative 0.52 standard deviations below the mean? By the way, we do have a shorthand way of saying number of standard deviations, and that shorthand way is called Z-score. So another way to say this is what percent of data is below a Z-score of negative 0.52? Z is the number of standard deviations either below the mean or above the mean. In this case, they're below the mean. Oh, and by the way, there is a typo here. This should not say negative 0.52. Let me see if I can cross that off. Now, technically, we are looking for negative 0.52 z-score, but when we say below the mean, we can actually say 0.52 standard deviations below the mean. And we'll see what that looks like when we use a z-table in just a second. Okay, so let me get back to our presentation here. So first of all, I want to tell you guys how you can use your textbook z-table. When you go to the z-table that's at the back of your textbook in the appendices, there will be two pages for z-tables. There's a left-hand page and there's a left-hand page and there's a right-hand page. So you're going to be looking for, in this particular case, because we're dealing with a z-score that is negative, and by the way, it doesn't matter whether the shading is to the left or the right. We're only concerned about is the z-score negative or positive. Because we're looking at a negative z-score, one that is to the left of the zero, or the left of the mean, I should say, we will look on the page that has a picture that looks something like this, where it says, where it has shading and the z is to the left, clearly to the left of the mean, okay? And then you can see that the shading just happens to be the left, like our picture. Anyways, let's go ahead and let's take a look at a z-table. Now, in this particular z-table, I have the z-scores on the left. I can't remember whether that's true in your textbook or not, but for your z-scores could be on the left or the right, depending on which page you're on. Just look for the z at the top of the table. Anyways, we're looking for a z of negative 0.52, and again, that's positive 0.52 deviations below the mean. But we're looking for a negative 0.52. So that's our z-score. That is the number of standard deviations. So negative 0.52, I come down to here, I see negative 0.5. Now you'll notice there is no negative 0.52. In order to find the negative 0.52, I have to go up to the columns. This would be for negative 0.50. This would be for negative 0.51, and this will be for negative 0.52. So what I do is I come down to this column and this row for negative 0.5, and what I see is 0.3015. So my answer here is going to be 0.3015, but I usually don't express it in that way. The answer is going to be expressed as a percent, which would be 30.15%, and that is what the shaded area represents based on this table. Let's look at some more examples. So in this example, we're looking at the percent of data that is below 1.31 standard deviations above the mean, okay? Again, it's a z-score of positive 1.31. Z means how many standard deviations. And it is a little bit odd that you can have 1.31 standard deviations. I mean, think about it. We understand having one apple or two apples or three apples, right? And we kind of got one standard deviation or two or three standard deviations. But it is a little bit weird having 1 1.31 apples. And it is a little bit strange having negative 0.52 apples, okay? But in standard deviations, we can have partial standard deviations. So 1.31 is a perfectly legit number of standard deviations. Okay, so this case we're above the mean, so we're going to use a different page. We're going to use a different z-table page. So if you look at the z-table at the back of your textbook, you'll see that there's a different page, and on the separate page, it'll have a z that is to the right or higher than the mean. And that's what we're looking for here. Now you'll notice that the shading is still to the left in both, in the diagram, but that's just a coincidence. Our main thing we're focusing on is where are the z's. We should be looking at all positive z values. Now let's take a look at a z table so you can see what I mean. Notice here all the z values are positive. And again, I can't remember in your book whether you're going to see the z's on the left side of the table or on the right side of the table. But the main thing is you're going to look at the top for where it says Z, and then you'll know those are the z-scores, okay? All of these other numbers are decimals that represent percents, and that's how we get stuff out of this table. So, and then on top is just the second decimal place for the Z. Okay, so let's do the math here. So we're looking at 1.31 above the mean. The above the mean tells us which table to use. And again, looking at the z-score and seeing that it's greater than the mean tells us to look for the picture in the book where the z is greater than the mean. Okay, so now let's look at for 1.31. We know we want a z of positive 1 and 0.3. But we want to go to 1.31. So we can't go to this column because that's 0.00. We've got to go to the column with 0.01. So this will be 1.31. So in this case, if we want to know what percent of data is below 1.31, we're going to say that it's 0.9049. And we'll write that as a percent as 90.49%. Now, when you're doing your work on your problems and you're making your picture, I want you to shade the picture in the way that you see here. I want you to shade everything under the curve that is either to the left of your cut point or to the right of your cut point. By the way, I do want to introduce some terminology. This line here we're going to call a cut point. The line where you are at the number of standard deviations of interest, we're going to call that a cut point. Let's go on. Let's see what I've got next for you. So in this case, we want to know what percent of data is above 1.76 standard deviations above the mean. So again, we have a z-score that is greater than the mean. We have a positive z-score as opposed to a negative one over here. So that means we have to use a certain page in the z-table. Let's take a look. The page in the z-table that we're going to have to use is going to be the one where the z is greater than the mean. And we can sort of doubly verify that we're looking for z-scores that are positive because they are greater than the mean. So, so we're looking for 1.76. So here's 1.7. We got to go to 0, 1, 2, 3, 4, 5, 6. And that'll be 0.9608, which can be written as 96.08%. Now, one of the things that I would love for you to do is to try this in your own z-table in your own book and double check and see that you can find the exact percent that I found when you have the exact z-score that I have. All right, let's try another example real quick. Okay, so in this case, what percent of data is above 2.24 standard deviations below the mean? So again, we're looking, this is kind of interesting because the shading is, hey guys, I just realized I goofed up totally, not totally, but partially in that last example, so I'm coming back to it. And I'm leaving my mistake in because I want you to see that making mistakes is a natural part of mathematical thinking and problem solving. We don't just brush our mistakes under the rug, we reflect and think about them. So I was looking at my next slide and I came to realize there was something wrong with the percent I found around here. I said 1.76 would get me 96.008%, would be above the mean. Well, look at the shading here, okay? The shading does not look like it's 96% of the area under the curve. And I'll back up just for a second so we can see the whole thing. Look at this. This entire curve represents 100% of data. There's no way that that shaded area is 96%. So I made a mistake. What the deal is when you're using the table to find shading, both of the tables, both pages of the Z table in the textbook show you what happens if you have, if you want to find the percent of area that is to the left of your Z-score or under your Z-score, okay? So if you ever want to find the percent that's above, we're going to have to do something different. And here's what that different thing is. We're going to take 100% and subtract the percent we found, and that will be the percent of interest here. So in our case, we're going to do 100% minus 96.08, and that'll give us the correct percent. So what you'll notice is that if we do 1 minus 0.9608, what we get is 0.0392, and that's 3.92%. And that makes a lot more sense. And this is another great reason why, of the 3 rules that we have for doing normal calculations, the 3 rules are all make a picture, make a picture, make a picture. Okay, so hopefully you guys are game for another example or so. Let's take a look at another example. This one, again, the Z-score is below the mean, so it's a negative Z-score, and the shading, again, is to the right. So I'm going to let you guys try this one. I'm going to pause. Let's pause the video, and let's see if you guys can figure out what percent of data is above 2.24. It'd be great if you could do it. Okay, I'm hopeful that you tried. Now I'm going to go ahead and take a quick look. So first I'm going to go to the appropriate Z-table page, the one where the Z is less than the mean. And then I'm going to go look at the Z-scores, and we're at 2.24. Now notice we're at 2.24 below the mean, so we will be looking at negative Z-scores. Okay, and so we'll go to 2.2, and then we'll go over to 2.4. And so this is negative 2.24 right there, negative 2.24, negative 2.24. So that'll be 0.0125. Now again, clearly this blue shaded area is not simply 1% of the entire curve. So in order to get the correct answer, we'll have to do 1 minus this number, and that'll be the percent of our answer. I'm going to expect that you guys could do that on your own. So I'm going to go ahead and let's keep going. Let's go on to the next example. Here we go. All right, so here's one where we'd like to find the percent of data between 2 Z-scores, and I just happened to pick a negative Z-score and a positive. I could have done this between 2 negative Z-scores, or I could have done this between 2 positive Z-scores. The point is simply that I'm interested in figuring out the area between 2 Z-scores. Now, the only trick here, it's the same exact process. The only difference is we're going to find the bigger percent. Well, I'm actually going to find the smaller percent first. We're going to find the smaller percent. Then we're going to find the bigger percent. Then we're going to subtract the bigger percent minus the smaller percent, and that'll get us the area in between. So let's go ahead and take a look. So first we're going to look at, I really should be looking at the positive Z-table first, but this thing's already set up, so I'm going for it. So we're looking at negative 0.73. So that's, here we go, negative 0.7. If we go over to 3, here we are, negative 0.73. So we're at about, what just happened here? My shading is off. Dang it, hold on one sec. I figured it out. I clicked on the slide. Okay, so anyways, negative 0.7. Let's go over here to 3. So that looks like about 23.27%. We need to write that down. I'm not writing it down, but it needs to be written down. So anyways, approximately 23% is the smaller percent here. to the one to the left. Now, we're next going to go ahead, go to now I have a positive z table, so we'll look up 2.42. So 2.4, and we'll go over here to where the 2 is. Be careful, there's a couple of rows of z-score numbers. We're looking at this bottom one here. So negative, we're looking at positive 242. That'll be 99%. So if we subtract 99.2% minus the 23% we found, we would then have the area. In other words, if we go from the left of this cut point and we subtract off the area that was to the left of the first cut point, then we should get the total area that is between the two cut points. So far we looked at how to find the area under a normal curve if we were given z-scores. But in the real world, mostly we don't get z-scores. Mostly we have x values. So we're going to learn how to convert from a z-score to from an x value to a z-score. So a z-score is the number of standard deviations above or below the mean for a particular value in a data set, which could be called a score. And here is how to calculate a z-score if you're given a score. So let's say that you have a score or a value for x, and you have the mean and the standard deviation. You could use those three things to calculate z using this formula. So let's try it together. So we're going to go ahead and we're going to convert some x values into z-scores. We're going to take a practical application. Let's say that you were designing a machine to fill up cans with soda, maybe an energy drink. And the can, it was on the label, it said that each can has 16 ounces. But a lot of times when you're making machinery or you're producing something, a lot of times there is some variation. So you can sometimes get more and you can sometimes get less. So the can actually has a little extra room in it. So it does so it has a little more room than for just 16 ounces. Let's say that your machinery is designed to give on average 16.5 ounces with a standard deviation of about 0.3 ounces. Let's find the z-scores for the following x values. Now, the reason we're doing this is so that you can then use the z-table to figure out the percentage. So in the question, we ask the question, what is the probability that a can chosen at random has less than 16 ounces? We're not going to find the probability. All we're going to do is find the z-score, and I'm going to let you use that capability to find the percent for problems that are like this. So in this case, what are we going to do? We're going to use the formula. And the formula goes something like this. We have z is equal to, my little z, I like putting a little dash through my z, is equal to whatever our x value is minus our mean divided by the standard deviation. That's how we're going to figure out, that's the formula. And so if we know that, by the way, we're going to call this 16 ounce our x. So we're going to say x equals 16. And then we already know that the mean, the mu, is the mean. So that's 16.5. And the standard deviation, the sigma, the lowercase sigma, is going to be 0.3. So all we got to do now is plug this stuff in, and we'll be able to do the formula. So we'll say z is going to equal, let's see here, we'll do x minus mu, so 16 minus 16.5. And you'll notice that I'm going to get a negative z value here. And so if I was going to use the table, I would use the negative z value table. We'll divide by 0.3. And I'm not going to do the math. You guys could do it just as well as I could with a calculator. You just subtract and then divide. And then you'll go to the z table and look it up. Let's take another example. And let's do, what is the probability of getting more than 16.2 ounces? So in this case, we're going to say that in this case, x equals 16.2. Even though the one problem was what's the probability of getting less than, and the other problem is what's the probability of getting more than, we still calculate the z in exactly the same way. We're going to go ahead and we're going to say z equals, and again, it's going to be the x minus mu divided by the standard deviation. That's what z is. So we'll say 16.2 minus 16.5, and you'll notice that again we are below the mean, so we'll be using a negative z-score and then divided by 0.3. And again, I'll let you use your calculator for that. Most importantly, I want you to see how to use the formula to find z, and you're going to be doing that in some practice problems. All right, let's go ahead and try yet another variation of this. And for the next thing, what we'll look at is what if we had to find between two values? Well, there's just two x values. Again, all we got to do is find the two z values. And again, the formula for z is z equals x minus mu divided by sigma. And so we'll find the first z-score. And again, you can choose whichever one you want for the first one, but I'll do 16.4. So we'll do 16.4 as our x value minus our mean of 16.5. That'll be a negative z-score, and then divide by 0.3. And then when I have to find the next z-score, I'll do 16.7 minus 16.5, which is the mean, and divide by 0.3. And you'll notice this guy is going to be a positive z-score because 16.7 minus 16.5 gets you a positive value. Okay, now I think you have all the tools that you need to solve some problems, so let's get cracking.